Good morning, good morning, good morning. Okay, so what we're going to be doing today are calculating tangent and normal lines to a curve. So these are going to be equations that are based off of a slope and a point, so you're going to need to remember your point-slope form. It's also important to note that the slope of the tangent line is equal to the derivative of the function. So we're going to jump right into an example because I honestly believe that's the best way to do this. So the example is, I would like to find the equation of the tangent line to the curve y equals 3x squared minus 5 at the point 2, 7. So the first thing I'm going to do, after I make sure I have a complete xy pair, is I'm going to take this curve function and I'm going to calculate the derivative. Okay, so my goal here is to find the tangent line equation to that curve at this point. So the first thing I need to do is I need to take the derivative of my curve. So this is power rule, sorry. I drop the 2 down, it becomes 6x. The minus 5 goes away. Then I take that derivative and I solve it at the x value of the point I'm trying to find the tangent line at, which here is 2. So I get 6 times 2 is 12. This then is the slope of my tangent line. All I need to do now is I need to take this slope and this point and write the point slope equation for it, okay? So point slope is y minus y1 equals m times x minus x1. So my equation is going to be y minus 7 equals my slope 12 times x minus 2. I always like to go ahead and multiply it out and put it in slope-intercept form because I think it looks nicer. So when I do, I get y minus 7 equals 12x minus 24. Add the 7 over, and I get y equals 12x minus 17. So this is my tangent line equation. So what if I wanted to go one step farther, and I wanted to find the normal line? So the normal line is a line that runs perpendicular to my tangent line. So I'm still going to be using the same point, but my slope is going to be the slope I calculated, but it's negative reciprocal. So the slope of my normal line is going to be negative 1 over 12. I'm going to do the same process. Y minus 7 equals negative 1 over 12, x minus 2. And then I'm just going to go ahead and simplify it out from there. Y minus 7 equals negative 1 over 12x plus 1 over 6. I go ahead and I add the 7 across. Well, 7 over 7 written as a fraction over 6 would be 42, plus 1 is 43. So I get y equals negative 1/2 x plus 43 over 6. And I'm done. So here's my tangent line. Here's my normal line. So let's just go ahead and do another example, but they really don't get any more complicated than this. So another example I have is a function equal to 9x to the 4th minus 6x squared plus 3 at x equals negative 1. So like I mentioned before, I really can't start until I have a full xy pair. So I need to take this x equals negative 1 and I need to plug it into that equation for x. When I do that, I go ahead and get the answer of 6. So the point I will be using is negative 1, 6. Now I need to calculate the slope of my tangent line. So I need the derivative function, which is 36x cubed minus 12x. I'm going to take negative 1 and plug it into that. When I do, I get negative 36 plus 12, which is a negative 24. So my slope then is negative 24 for the tangent line. So I'm going to go ahead and do my point slope form. Y minus 6 equals negative 24. X minus a negative 1. Distribute and combine. I get y equals negative 24x. Minus 24 plus 6 is a minus 18. So this is my tangent line equation. So TL. I would like to go ahead and find my normal line then. So NL. I'm going to take the slope I calculated, which is negative 24. I'm going to flip it and take the opposite sign. So my normal line equation, slope, is positive 1 over 24. And then I do my point slope form. And I combine like terms and get into slope intercept. 1 over 24 times 1 is just 1 over 24. Plus 6 is going to give me 1 over 145, over 24. This is my normal line. This is my tangent line. So now we're going to work a little bit backwards. And this is kind of going to be the last example that we do. So it says that my tangent line equation is y equals 27x minus 7 to the original curve y equals x cubed plus 6x squared plus 12x plus 1 at some point, and it wants us to find what that point is. Okay, so the first thing I need to do is I need to pull out the slope from my tangent line, because that's going to be equal to the derivative of my original graph. So then I need to calculate that derivative. When I do, I get 3x squared plus 12x plus 12. And that's going to be equal to 27. And I'm going to need to solve. I'm going to subtract the 27 over. I'm going to go ahead and factor out a 3. I recognize that this factors into x plus 5, x minus 1, which gives me x equals negative 5, and x equals a positive 1. So here I have the start of 2 different points. I need to figure out which of these points would give me this tangent line. So in order to do that, I have to know the y value that's associated with each of these points. So I'm going to take negative 5, and I'm going to plug it in to this equation. When I do, I get a negative 34 as my y value. I'm going to take positive 1 and plug it in. When I do, I get positive 20 as my y value. So these then are the 2 points I'm going to be using to try and create this tangent line. Because I know what its slope is, it's 27, and I have a point, so we're just going to do point slope form. Okay, so I'm going to drag this over. I'm going to go ahead and do negative 5, negative 34 first. So I have y minus a negative 34 equals 27 times x minus a negative 5. Distribute and combine. I get y equals 27x. 27 times 5 is 135 minus 34 is 101. That does not match the tangent line that I calculated or was given, So it's probably going to be this point, but we still have to prove it. So I go ahead and do point slope form here. I get y minus 20 equals 27 times x minus 1. Distribute and combine. I get 27x minus 27 plus 20 is negative 7, which matches the tangent line that I was given in the problem. So this is the point at which that is my tangent line. The last little piece of information then that I'd like to give you is that a graph has horizontal tangents wherever my derivative is equal to 0. And also, as a nice little reminder, normal line is perpendicular to our tangent line. So that means the slope of my normal line is a negative reciprocal to the slope of the tangent line. Any questions, please let me know.